This is the prerequisite review for section 4.4, Properties of Logarithms. We have one objective on this worksheet, and it is simplifying expressions with exponents. Let's go over a couple of the exponent rules. If we have x to the a multiplied by x to the b power, we will add those exponents, together. However, if we have x to the a raised to the b power, we will multiply those exponents together, okay? So, same base, we add the exponents, power to power, we multiply them. Let's go ahead and give that a try. Looking at number 1, we can see we have the same base, so we will be adding those exponents together, and we arrive at z to the 8th power. Now we do need to be careful because this a has a first power there. So that is a to the 1 plus 8, and that is a to the 9th power. Now, looking at number 3, I suggest getting your coefficients together and multiplying those first, and then going ahead and putting your variables in order or in line or next to each other. So as you can see here, we have 24 divided by 3 is 8, multiplied by 2 is 16. You can also go ahead and do that, find that in your calculator as well. So I hope that helps. Okay, so now we will take care of our variable m. We have 13 plus 7 and n to the 8 plus 2 power. And you're actually able to go right to this m to the 20th, n to the 10th power. Let's do the same thing, and I'll go ahead and put parentheses around that. Let's take our 10 multiplied by our 2, our y to the first, multiplied by y cubed, and we arrive at 20, and let's just go ahead and add those exponents together this time. Now, as you can see in number 5, we will be subtracting our exponents. So when we have the same base, you could almost think of this 3, 4, 5, 6, 7, and just 6 W's in the denominator. And as you could see, you could almost think of this as having 1 W remaining in the numerator. So here we will have W to the 7 minus 6. So instead of adding, we will subtract our exponents when we divide. Okay, so here we will have W to the 7 minus 6, and then that is W to the first power, and we will just write W. Looking at number 6, here we will add first so we end up with W to the 14th divided by W to the 9th. And now we will subtract and have W to the 5th power. Okay, let's do the same thing that we did before. Let's go ahead and take our numbers first. So negative 12 divided by 4. We'll have s squared over s to the first. We'll have t to the first, and we'll have u cubed over u squared. And this makes it much nicer. So we'll have a negative 3, and that is s to the 2 minus 1, t to the first power, and u to the 3 minus 2. So as you can see, we have negative 3s to the first power, t to the first power, and u to the first power. So all of these are to the first power, and we have negative 3s tu. I'll make that a tad bit smaller so that we can see our next problem. Now here we go. This is raising a base to a power. So this is w to the 7 times 2, which is y to the 7 times 2, and that's y to the 14th. Now keep in mind that is this second example. When we take a base that has a power and we raise it to another power. I call that power to power. Okay, let's go ahead and take a look at number 9, and you can take these step by step. So we have a to the 2 plus 4, and once we get that, we'll raise that to the 6th power. So we have a to the 6th raised to the 6th, which is a to the 6th times 6, and we have a to the 36th power. Looking at number 10, this is a really important property. Let's write something out to the side. Keep in mind that if you have x, y to a power, each one of those factors get that power. Okay? It's almost like distributing that power. So in this case, we are going to have 5 squared multiplied by w squared. So we have 25w squared. Okay, looking at number 11, each one of these factors get that power of 2. So we end up with 25 x squared, y squared, z squared. As you can see here, we have power raised to a power. So we have negative k raised to the 6th times 3 power. So we have negative k raised to the 18th power. And actually, we probably want to take care of this negative sign. Let me do something here real quick. So when we cube something, I'm going to go ahead and change this, because that is a correct answer, but not the right way to explain it. So we have negative k to the 6th cubed. So you could think of it as negative k to the 6th multiplied by negative k to the 6th multiplied by negative k to the 6th. And as you can see, we would have the same base of negative k, 6 plus 6 plus 6. Okay? You could also think of this as negative 1 cubed multiplied by k to the 6th cubed. So you would have a negative 1 multiplied by k to the 6 times 3. And you'd have a negative k to the 18th. So there's several ways that you can do that. Okay, let's look at number 13. Every factor is going to be squared. And there's a couple ways that you can do this. So my way isn't the only way. And here, as you can see, We have 4. We're going to multiply those exponents, multiply those exponents, multiply those exponents. And now we will subtract. So we have 4/9. Let me rewrite that. And then C, 6 minus 4 is 2. D, 8 minus 2 is 6. Okay, here in number, make that a tad bit smaller. Here again, the same base, we will add our exponents, and then that would be 1 divided by x to the 4th. Or, there's lots of ways, we could have had 1 over x to the 8th times x to the 4th, and you would have had an x to the 4th over x to the 8th. And that's to the 4 minus 8, x to the negative 4, and we're back to where we were. Lots of ways to work these. Now, on number 15, let's take a look at this. There's 3, and then we have 2, 4, 6, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you take a look at this, when you have more in the denominator, a higher power, you actually have the subtraction done from the denominator with that many remaining. So this is p to the 3 minus 9, which would leave 6 in the denominator. So I hope that that illustration is helpful. It does help sometimes to see that like that. Okay, here we have u to the negative 2 minus a negative 6. Again, when we divide, we subtract our exponents, and we end up with u to the 4th. Let's take a look at number 17. We're going to do the same thing. It's the same base. Since we're dividing, we are going to subtract those exponents, and that's 3 plus 5, and that is p to the 8th. Here we have another property. We are going to have 2 to the negative 3rd divided by 7 to the negative 3rd. We're going to take the 2 to the denominator and make its power positive. We're going to take 7 to the numerator in order to make its power positive. And we do that to remove the negative in front, remove the negative exponent. And now all we have to do is cube 7 and cube 2. Okay, as you can see, this is 7 times 1 divided by y, and we end up with 7 over y. Now keep in mind here, each of these factors get that negative 1, so that's a 1 over 3 times a 1 over z, and we end up with 1 divided by 3z. Now, using those examples, what did you notice about that negative? You could just reciprocate each factor if you would like. So we would have 2m to the 12th n to the negative 2 over 4m to the 10th n to the 4th. You could just do that, or you could have distributed. Either way. So now all of this is to the first power. So we take our constants, we take our each one of these variables and subtract their exponents. So we have 1/2, and this would be m squared, but this would be n to the negative 6. So that m squared stays in the numerator. Again, keep in mind there's a 1 under here. And then the 2n to the 6th is now in the denominator. So just taking a little bit of time, there's several ways to work each one of these ways to simplify the expressions. And that concludes this